Welcome back to the Calculus Summer Packet Review, and we're going to be looking today at the transformation of functions. Take a look here at the left-hand portion of the screen. You don't have to always have a polynomial that you're working with for a function. You could have a piecewise function. We're going to talk about that in another video very soon, the next video in fact. But let's just say we do have a piecewise function, a graph that looks something like this, made out of four line segments joined together at their endpoints. And most notably, I want to point out that you could look at the corner points and label them as ordered pairs. This would really define your shape. Well, let's just say we have such a function and we would like to do some changes on it. We'd like to transform it. Let's take a look at what would happen given this function if we had y is equal to the opposite of f of x. If that were true, if we wanted to look at what's happening, if that's what we were being asked to do, first notice that f of x is really just another name for y. So the negative is going to be applied to the y coordinates on the original function. The x values, in other words, are not affected. Let's just say we've got negative 3, 0, 1, 2, 4. But look at these corresponding y values. They're all going to have a change. We're going to multiply them by negative 1. That's what that negative out in front will do. A 0 will not change. It's going to stay as 0. The 2 will change to a negative 2. Let's just see what would happen if we tried to join these endpoints together right now. If we had 1, 2, 3 steps to the left, 0, comma 1, all of a sudden you'd say, wow, that's interesting. This point is now up here. 1, comma 0 is joined over here. 2 to the right down 2 would be this way. And 4, comma 0 would be this way. Now, of course, my graph here looks slightly different. We don't have quite the same axes and spacing and so forth. But I hope you can notice, compared to the original function, there's been an obvious change. Hopefully you remember talking quite frequently about how a negative out in front of f of x will be a transformation, a reflection of the original curve over the x-axis. What that's really saying is all of the y coordinates are going to change sign, and if they're 0, they will remain 0. Let's take a look at this next transformation, negative 2 times f of x. Well, again, something to think about is that the negative 2 is being multiplied to the y values, leading us to realize that our x values will remain unchanged. But just multiply all the original y values by negative 2. Of course, 0 times anything is going to remain as 0. But you can see very quickly that we'd have 0, 2, 0, negative 4, and 0 now, multiplying negative 2 to that original table. Let's see, negative 3, 0 is right over here. 0, comma 2 would be lifted up over here. 1, 0 is this way. 2 to the right, down 4 is going to look just like so. And 4, 0 is going to be just over here. If you're thinking that this is going to be very, very close to the original, the last problem that we just did, you're right. You can see it's definitely a similar shape. However, there's been a vertical stretch. That negative 2 has really doubled all of our y values on that last graph that we had done previously. The negative, of course, results in a flip, a reflection about the x-axis, but that 2 there is going to be doubling all those y values, doubling their respective distances from the x-axis. Let's take a look at y equals f of x plus 1. For the first time in this video at least, you're seeing that the arithmetic involved is applied to the x. You can see the plus 1 is directly next to the f of x, to the x itself. This can help us remember that we could have X-Files. Now, X-Files was the name of a movie and a TV show back in the 1990s. And many teachers in our school will actually refer to transformations involving X, referring to them as, hey, remember X-Files. X-Files dealt with the paranormal. It was a TV show that dealt with UFOs and vampires and very weird stuff. The fact is, when you see arithmetic on X, it's going to be a weird transformation. You would expect, of course, for us to have some kind of an effect on the X coordinate, and we will. You might think that, oh, we're just going to go back to our original table and add a 1 to all of the X values. Actually, it's the exact opposite. Because of X-Files reverse logic, we're going to subtract a 1. So look at your X values in the original table here. -3, if you subtract a 1, you'll be at -4. 0, subtract a 1, you're at -1. At 1, if you subtract a 1, you're at 0. 2, subtract a 1, you're at a 1. 4, subtract 1, you're at 3. And the wonderful thing is your Y values right now are going to remain unchanged. So if we were to graph this out very quickly, plotting all of these points, I think you could quickly see that, yeah, we do in fact have a graph that will be reminiscent of the original function. What you hopefully are noticing is there's been a shift to the left. We go one step left from the original graph. And, with movements with X, if you see X plus or minus a number, you will move right or left. It's just that we're going to go in reverse logic fashion. Take a look at what would happen if you saw X minus 2. Well, you might guess, once again, we've got X-Files, and we do. We're not going to subtract a 2 this time, though. We're going to add a 2 to all of our X values. -3 plus 2 would be -1. 0 plus 2 would be a 2. 1 plus 2 is a 3. 2 plus 2 is a 4. And 4 plus 2 is 6. And again, the wonderful thing about this is all of our Y values are remaining unchanged. We'll be right here at -1, 0. 2, comma, -1. 3, comma, 0 would be 1, 2, 3 right here. 4, comma, 2 would be up this way. And then 6, comma, 0 would be right over here. So what you should have picked up here is that we're going right 2 steps with the original graph. As we move on to y equals f of 1/2 x, here we go again. I hope you notice that the 1/2 is being multiplied to the x. Now, multiplying by 1/2 is actually the same thing as dividing by 2. So again, you would think, oh, I'm affecting my x coordinates. It's very tempting to say I'm just going to divide all of them by 2. I'm going to take half of them. But again, this is X-Files, and we're going to do the exact opposite of what you originally think. Instead of dividing by 2, we're going to multiply by 2. Look at that top left corner of the screen. Take a look at those X coordinates, just the X coordinates. Double them all. Multiply by 2. -3 times 2 is -6. 0 times 2 is still a 0. 1 times 2 is a 2. 2 times 2 is a 4. And 4 times 2 is an 8. And again, what's kind of nice is all of our y values are going to remain fixed. Now at this point, usually what I would do right here is very quickly change the scale. I would notice it looks like from our last graph when we went out to 6, on the far right side, it was right at the edge. Like I said, ordinarily I would do that. Right now, I'm not going to. On your homework and so forth, you should. But I just want to make a point compared to relative size, comparing to what we started off with. If we went -6, 0, That's all the way over here. 0 comma negative 1 is down here. 2 comma 0 would be right over here. 4 comma 2 would be up here. And then 8, well, here's a 6, and here's a 7, and here's an 8, just trying to plot that out. Why am I extending it instead of changing the scale? Just to really drive home that this is a horizontal stretch. It's taken the original graph and it's really doubled all those x values, stretching them out, their distance from the y-axis. In other words, the x-coordinates distance from the y-axis. Helps you see that maybe a little more clearly. Okay, a couple more problems that we'll take a look at, and then we'll wrap up. I've recopied the table of the original function off on the left-hand side, just for the sake of space. And let's take a look at the absolute value of f of x. The absolute value, I hope you're looking at this right now and noticing that the absolute value is applied around f of x. It's applied to the y values. So as you might have guessed, the x values are going to remain unchanged, but all of the y values, we're going to be taking the absolute value of them. Absolute value of 0 is 0. Absolute value of a negative is a positive. If you take the absolute value of a positive number, it remains positive. Let's go ahead and see what this graph might look like. Negative 3, 0. 1, 2, 3 steps to the left. There it is. 0, comma 1, we're up here. 1, comma 0, we're over here. 2, comma 2, that's going to be lifted up, 2 to the right, up 2. And 4, 0, well, 1, 2, 3, 4 would be right over here. So, my goodness, as you were to graph this out, you might wonder how this would pertain to the original curve, the original piecewise function. Let's take a look at it together. The original graph looked like so. And if we're taking the absolute value of our y values, if they're positive, they remain positive, of course. But look what's happening when we took the absolute value of these negatives. Anything that was negative, of course, was reflected upwards. So what we have very nicely is a reflection of that green highlighted curve over the x-axis. That's now going to be reflected above. And that's effectively what we've just seen. So if our y values were positive, they remain positive. If they were negative, they're reflected up above to represent the positive part. Okay, one last problem, and let's take a look at f of the absolute value of x. Very different problem, because the absolute value now, I hope you can see quickly and easily, is applied to the x. Now, I want to point out to you something, that the absolute value of positive numbers remain positive. And the absolute value of 0 is 0. So when I take the absolute value of 1, I still get a 1. When I take the absolute value of 2, I get a 2, and so forth. What's so nice about this is you're going to see very quickly that what's occurring is that when we're dealing with x values of 0 and positive x values, our graph is the same as it was before. But something very interesting is going to happen when you're taking the absolute value of this negative 3. What's happening is when you're taking the absolute value of this negative 3, you need to realize that the absolute value of negative 3 is actually going to arrive at a positive 3. And that should give us something to think about. Okay, we're running out of time. We're going to have to pick this up again just to finish this off. So we'll continue that on the next video.